Number 4 on the extra practice, part A asks us to find all critical numbers. Critical numbers are where the derivative is 0 or undefined. So we need to find the derivative of this. We're going to use the product rule. It's this times that. So it's the first one times the derivative of the second one. Derivative of the second one is just 1 plus the second one times the derivative of the first one. So the derivative of the first one is 2 times x plus 2 to the first times the derivative of the inside, which is 1. So that's the derivative of the first one times the second one, so times x minus 4. We need this to be equal to 0. To solve this, I've got two terms here, one right here and one right here, and they both have an x plus 2 in them. So I'm going to factor an x plus 2 out. If I take one of the x plus 2's out of this, I still have an x plus 2. And I took this x plus 2 out, so I'm left with plus 2 times x minus 4. Distribute this 2. And combine like terms. So the factored form of the derivative is 3x minus 6. Set each term equal to 0. I get x equals negative 2. If you set 3x minus 6 equal to 0, we get x equals 2. Those are our critical values. The derivative, notice, is never undefined. To answer B and C, we need to make our derivative chart. Our critical numbers are negative 2 and 2, so we're going to go negative infinity to negative 2, negative 2 to 2, and 2 up to infinity. And we're plugging a value into the derivative. You can either plug it in up here, or you can plug it into the factored form way down here. Either way will work. If I plug in negative 3 down here, I get negative 1 times negative 15, which is positive. Negative times negative. If I plug in 0, I get 2 times negative 6. If I plug in 3, I get 5 times 3. So the derivative changes from positive to negative at negative 2, which makes this a max. Changes from negative to positive at positive 2, which makes this a therefore, we have a relative maximum at negative 2, relative minimum at positive 2. To get the y values, we go back to the original equation. So if I plug negative 2 in, I get 0 squared. That's 0 times negative 6, which is 0. And if I plug in positive 2, I get 4 squared times 2 minus 4. So this is our answer to part C. Identify all minimum and maximum values. Part B lists the open intervals where it is increasing and decreasing. So we are increasing when the derivative is positive, so negative infinity to negative 2, and from 2 to infinity. And we're decreasing where the derivative is negative, which is this interval right here, negative 2 to positive 2.